Now, I'd like for you to state the condition for how fast do we have to sample the signal so that this aliasing doesn't happen. Okay?
Mm-hmm.
So this is at 1 over t sub, I'll remind you, this is at 1 over t sub s.
Uh-huh.
And this goes to frequency w.
Okay.
Okay? So what are the constraints on t sub s or correspondingly f of s, the sampling frequency, so that we can recover the original signal? So think about what the constraints are so that these don't overlap. And remember, these all have the same bandwidth because they're from the same spectrum.
Right.
Let me know if you need a little nudge.
Yeah, please.
Okay, here, I'll draw it. I'll draw it with where they don't overlap. Okay, so we have some signal.
Uh-huh.
It's at 0 over t sub s, centered at 0 over t sub s, and it goes to w and minus w.
Yeah.
Then we have another one that's at 1 over t sub s, and it's from minus w to w.
Okay.
And we'll have another one that's at 2 over t sub s. Same thing, w minus w.
Okay.
So we need this not to touch this.
Okay.
So how can we write that constraint?
So this distance right here is 1 over t sub s.
Mm-hmm.
Okay. So it seems like this distance right here is 1 over t sub s times a half.
Yeah.
So then w has to be less than or equal to 1 over 2 t sub s.
So write that in terms of t sub s. We
So
want it as or 1 over t sub s. We want it as a
so
function.
then 2w must be less than 1 over t sub s.
Very good.
Okay.
Mm-hmm.
So that is the condition.
And 1 over t sub s is equal to f sub s, which is the sampling frequency.
Okay.
So we have to sample the signal
Uh-huh.
at least w, or 2 times the greatest frequency component for
Okay.
this to work.
Okay.
And for some signals, in practice, like typically signals are band limited at some point, but there are some signals in theory which are not band limited,
Okay.
which are like the square wave. So you couldn't do this for a square wave
Okay.
because the square wave has an infinite number of terms.
Okay.
So they would always alias. There's nothing, you can't prevent that.